Hello folks, today's lecture is this continuation from the one we did yesterday. So today we're talking about periodic trend. Trend is a pattern that tends to be predictable. For example, I see a lot more people are buying brand name clothing now because they want to look a certain way, and that's a trend. People care more about clothing that actually has the brand on the outside compared to in the past. So that's just a trend, for example. So the atomic radius of an atom increases as you go down, because it has more layers. The more layers you add to something, the bigger the radius it will be. Common sense there. However, the first bullet point is not so much common sense, because this is a deeper analysis reason. As you go from left to right, the number of rows or layers are exactly the same in the same row. However, the atom will gain more proton in the nucleus, with more proton, which are positive in the nucleus, reaching out and grabbing the electrons and holding them in. As you go from left to right, the attraction will be higher. Therefore, the atom will get smaller as that radius is grabbing onto the electron even more. So the smaller the atom on the right is because the nucleus is getting bigger in terms of power and is pulling the electron in. So the pattern's right here. By the way, the opposite to the word increase is obviously decrease. So if you see an arrow that goes like this and it say decrease, that is also correct on your quiz. What is an ion? Well, like most of us, we all want to change something about ourselves because there's something that's not healthy or something that's not good about us. So a lot of atoms, if they don't have a full ring of valence electron, they will actually gain or lose a shared electron. And some of them that gain or lose will become what we call ions. So ions are an atom that has changed already to be more stable by gaining or losing an electron, and therefore becoming positive if you lose and negative if you gain negative electron. Now, when you gain electron, you're adding more electron to the atom. It's going to expand. If you stuff more thing into a bag, the bag will expand. When you lose a whole layer of electron to drop down to a full ring of 8 below, or a full ring of 2, you're obviously going to take off a whole layer. When you take off a layer, you're going to be smaller in terms of volume. Ionization energy is the energy it takes for you to try to steal one electron from an atom. When I have a bigger atom on the left side of the periodic table, as well as in the bottom of the periodic table, it is really hard for the nucleus to try to grab onto that electron. So atom that has big atomic radius will have very low ionization energy. So the two trends right here are the opposite to the atomic radius trend. Okay, so once again, bigger atom on the left side, specifically metal. Metal wants to give electron up. They're going to have very low ionization energy, because if you want to get rid of an electron and someone try to take one from you, you're going to resist very, very little. On the right side of the periodic table, when an atom wants to gain electron, like family 5, 6, and 7, if you try to take an electron away from them when it's trying to gain more electron, it's going to have much high ionization energy. So as you go from left to right, it increases because you're going to the non-metal side and they want to gain electron. As you go down a family, the atom is getting bigger and the nucleus is having more difficulty holding on to the outer electron. It's going to decrease because it's going to be able to resist less. Here's the trend. Now, once again, the opposite of increase is just the word decrease. Okay, so another way is you can say decrease going this way. Electronegativity or electroaffinity, write that word down, is basically a different way of saying ionization energy. So how much I am attracted to the electron is basically the same way as how much I'm going to resist losing it. If I'm attracted and truly have affection and love for my wife, I'm going to resist doing anything to make her wanting to leave me, right? So electronegativity is basically ionization energy. It's just stated in the opposite vocabulary, but it's going to have the exact same trend. So if you could draw like a rectangle for your periodic table and then copy down this arrow in your notebook. You get to use your notebook and periodic table on the test. So once again, the opposite of the word increase is the word decrease. So if you see an arrow going the opposite way, but it say decrease, it means the same exact thing, okay? They're just measuring your analysis skill. That we just draw, lowest left, biggest radius will be down here. somewhere over here, opposite to this side, right? Lowest electronegativity, as it increases this way, the lowest will be in the bottom, so it'll be francium Fe. Highest ionization energy is to the right and also up, right? So in the halogen family right here, the one that's the most up is fluorine. So with that, try to do this. Which of the following metal will react the fastest? As we said, metal, the one that's the fastest is the one on the far left. Family 1, family 2, group, somewhere in the transition metal, which is 3+. So it's going to be K because family 1 is the farthest left. Which atom will have the slowest reaction? Which one of these almost never react at all? And the family that doesn't react at all is the noble gases. Which atom will have the largest radius? The largest will be to the lower left of the periodic table based on that. And therefore, analyzing that, the answer should be cesium. Which atom will have the smallest radius? The smallest radius will be, so analyzing that, the answer will most likely be neon. Make sure you look at the periodic table yourself to understand this, because the understanding is more important. Which element in the alkali family will have the lowest electronegativity? Okay. Which element in the halogen will have the highest ionization energy? So with that, that's the lecture for today. Take the note, watch the video. Hopefully by now you're seeing the video, and then take your quiz, but make sure you think. One last thing I want to add is for atoms, you cannot measure the distance from the nucleus to the outer edge of the atom ever because of the fact that there's no clear edge. It's not a solid material. It's electron buzzing around, constantly changing. So you don't have a clear edge. What they do is they measure the distance between the nucleus of 2 atoms, and they divide that by 2. So when they have 2 oxygen atom or 2 iron atom and they divide that by 2, they know the radius because the radius is 1/2 the distance of the 2 nucleus being separated apart. So that's just something to note. With that, have a good day. I'll see y'all back on Monday.